All right, so let's dive into something that's always kind of bugged me. You know how there's this enormous gap between things that are mathematically possible and things that are, physically real? We've all seen concepts that look perfect on paper, but they completely fall apart when you try to actually build them. So what's going on there?
Okay, let's start with a classic. Just picture one of those impossible objects, like a Penrose triangle, or maybe one of M.C. Escher's incredible drawings where waterfalls are somehow flowing uphill. The thing is, we can totally imagine them. We can draw them. Heck, we can describe them with perfect mathematical logic. So, what's the holdup?
The holdup, it turns out, is reality itself. The second you try to take one of these perfect mathematical concepts and build it in our 3D world, the whole illusion just shatters. It can't make the jump from a pure idea to a physical structure. And that points to some kind of hidden boundary, right? A line between what we can imagine and what can actually exist. So, to really get a handle on this boundary, let's frame it as a kind of contest between two completely different realms: the world of pure mathematics and our own physical reality. You know, in the realm of math, pretty much anything goes. It is a world of absolute infinite possibility. You can define numbers so huge they couldn't possibly be written down in our entire universe. You can play around with a trillion dimensions if you want. But then, there's the realm of reality. And here, things are different. Reality is all about what's realizable. It's made of structures you can actually build, not just abstract concepts you can define. Here's a great way to think about it. It's kind of like a video game, right? The game designers can imagine all sorts of crazy, amazing things. But at the end of the day, the game's engine has hard limits. And no matter how cool an idea is, if that engine can't actually render it, it's just not going to show up in the game, period. It looks like our universe has a similar kind of operating system. Which, of course, leads us to the really big question. What is this engine of reality? What are the fundamental rules that are deciding what gets rendered into existence and what has to stay behind as just an impossible idea? Well, the theory that tries to answer this question has a pretty cool name. It's called physical vacuum architecture, or PVA for short. And what it suggests is that there's a hidden set of rules governing our reality at the deepest, most fundamental level you can imagine. The very first rule of PVA is called Axiom A0, also known as the domain. Now, it sounds fancy, but it's actually a simple and pretty profound statement. All it says is that the set of things that are physically realizable, let's call that R for reality, is just a tiny, tiny fraction of all the things that are mathematically possible. And wow, this visualization really drives that point home, doesn't it? Reality isn't just a part of math, it's a sliver, a tiny, tiny slice. Most of what's possible in the world of pure logic and numbers is, quite literally, illegal in our universe. So what do we even mean by physical here? Because in PVA, it's not as simple as something being made of atoms. It's really talking about physical realization. It's that all-important difference between an idea that only exists as a definition and a structure that the actual vacuum of space can support, or host. This whole idea forces a huge shift in how we think about the role of physics itself. It's not just about describing how things move anymore. It's about defining what's allowed to exist. See, for centuries, we've thought of physics as this grand search for the equations of motion, the math that tells us how a planet orbits a star or how a baseball flies through the air. But this new view from PVA suggests that physics is actually about finding the constraints, the fundamental rules that determine what's even allowed to be built and move around in the first place. Here's a great example. Think about a simple stone arch. It doesn't stay up because it's actively following the law of gravity every second. No, it stays up because its physical shape, its structure, is compatible with the constraints of geometry and pressure. Its very form allows it to exist within those rules. If you build it the wrong way, it collapses. Its existence is forbidden. So this is the crucial point, the big takeaway. The vacuum of space isn't just some empty stage where anything can happen. It has a fundamental structure, a kind of arithmetic language of its very own. And this architecture creates an invisible fence around our reality, letting some structures in while keeping others out. And that brings us right back to where we started, but now the question is so much deeper. If there really is a line between the possible and the impossible, then what or who is drawing it? I mean, really think about it. What is the fundamental property of our universe's architecture that says no to an endless staircase, but has absolutely no problem with a simple, everyday ruler? What is it that defines the boundary of our own existence? Well, the answer might just lie in the universe's, let's call it a budget. It seems the vacuum doesn't just limit what can exist, but also how much detail it can actually handle. So next time, we're going to explore this idea of a complexity bound and ask if our reality is, in a very literal sense, low resolution. I'll see you then.